Good evening, folks. Welcome to FASNY's webinar. This month, I've invited Jason Rivera to do a program on hybrid and electric vehicle incidents. Jason is a 30-year veteran of the fire service, both volunteer and career. He works with the New Haven, Connecticut Fire Department, currently assigned as a driver, Rescue 1. Prior to working with New Haven, he's a retired captain from the city of Sanford, Connecticut. He's a certified fire instructor, has been teaching for over 20 years across the country as well as internationally. He's presently a lecturer overcoming common engine company mistakes and fire ground problems at FDIC since 2017. He is also published in Fire Engineering Magazine on multiple occasions. He's the co-owner and founder of the fire service training company, Northeast Squad Concepts, LLC, which specializes in squad disciplines such as engine company operations, vehicle extrication, rope rescue, and RIT. In 2016, Jason received the Ray Downey Courage and Valor Award at FDIC after receiving 2 second and third degree burns on both his legs, waist, and wrist while operating at a structure fire in New Haven, where a successful rescue was made. Jason is also a rescue specialist for the Massachusetts Urban Search and Rescue Task Force and is past chief for the Newton Hook and Ladder Fire Company in Newton, Connecticut, and a volunteer firefighter in Christiana, Delaware. I invited Jason to present this topic after seeing and sitting through the program. It was a 3-hour program on this topic, and I think it's quite a timely topic with the hybrid and electric vehicle incidents coming up more and more. So I think you'll find this of interest. And I turn it over to Jason. And again, I think you'll find it of quite interest. Jason, why don't you go ahead and present what you have for us tonight? I'm looking forward to see. I know you're not going to have a 3-hour program for us, but I think you picked out some of the highlights that we spoke about.
Yep. All right, Charlie, thank you very much. Everyone out there, thank you for logging in. Do appreciate you spending an hour or so with me to discuss, like Charlie said, a very timely topic. It's a class that has really taken off for us. I think in this year alone, I've presented it somewhere about 55, 56 times in 5 or 6 different states, because it's something that we are all having to deal with. If you haven't dealt with it yet, it is coming. There's been times where I've taught this class and literally the very next day they responded to a lithium-ion incident. So the class is typically 3 hours, like we said. Tonight's not going to be 3 hours. You don't have to worry about sitting in front of your computer for 3 hours. I kind of narrowed it down. I took out a lot of the longer videos, just kept some of the shorter ones in there. The way the class typically runs is the first half of the lecture is going over hybrid vehicles. Hybrid vehicles have been around for quite a long time. They're really nothing new to us. And they haven't really given us many problems, at least in the early years. And a lot of that has to do with the battery technology that was used prior to about 2010. I don't want to get ahead of myself. We're going to get into battery technology and all that. And then typically we'll take a little break after we get through the hybrid stuff. And then we'll get into the electric vehicles. But we're going to talk about more than just EVs. We're also going to talk about micromobility. We're going to talk about energy storage systems, the Tesla solar roof. We're going to talk about structure fire issues. And we're going to talk about a bunch of different tactical options that we have. One of the fun parts about teaching this class is that, let me just make sure we go, is that it's an ever-changing, we are all learning. Like, I by no means am a subject matter expert when it comes to this. We see things like this, like we're showing in the video here, and people are like, well, what's going on? Like, departments are needing 25,000 gallons of water to put out a car fire, or they had to operate on scene for 5, 6, 8 hours. This is, absurd. It's unheard of. Typical car fire, what? We use maybe 300 gallons of water and we're in and out in a half hour. It's crazy what is going on right now. And a lot of that, this all has to do with the lithium-ion situation that we are dealing with. So we're going to talk about a whole lot of different things in the 3-hour class. Once we get through the EV, the lithium-ion, the micromobility, all that stuff, Then we go out and I bring with me a Tesla Model 3 and we take a look through it. The safety features, how to make the vehicle safe, how to shut down the high voltage system. And we do get into some specifics, extrication techniques that we have used historically. Some of them can no longer be done. And we're going to get into that with the program tonight. But then when we actually do the full program, when we actually go look at the Tesla Model 3, we take a further in-depth look at that. We're going to talk about a bunch of different tactical situations tonight as well. We're going to talk about accidents. We're going to talk about extrications, car fires, submerged vehicles. We're going to talk a little bit about hazmat, when we're going to talk about structure fire issues. We'll talk about submerged vehicles as well as battery breaches. So we're going to get through all of that as quickly as we can with the limited amount of time we have. In terms of questions, if you guys want to use the chat feature up top, I guess that would probably be the best way. And then when we get some questions, Charlie will jump in and kind of, tip me off that we got some questions to answer, because I don't want to wait to the end. I'd rather address the question for the topic at hand. And I encourage questions. Like, please don't leave tonight and not have a question answered that you wanted answered. I'll be happy to provide my email address too, so you guys can follow up with me later on, because I know we have limited time tonight. So, feel free to ask all the questions. Now, my two disclaimers though with questions is, number one, I am not an electrical engineer. And number two, I am not a car manufacturer. I don't work for a car company. So there may be, if you have some really technical specific type question, I might not have the answer for you. And I'm not going to bullshit you. I'm not going to, make up answers. If I don't know the answer, I'll tell you I don't know the answer. I'll do my best to find the answer for you, because I am in contact with people who are subject matter experts. So I'll be happy to try and find an answer for you and get back to you via email with it. But I will do my best to answer all your questions as best I can. For those of you, that, I probably haven't met a lot of people out there right now. My name's Jason Rivera. Charlie gave a pretty good dissertation about, my fire service career. I do a lot of fire service stuff. Most of it is not overly important to, this class specifically, but, currently I work for New Haven. I drive Rescue One, this citywide heavy rescue. I volunteer in the town I live in, so I see both sides of the coin. I work for a fairly large career department, and I volunteer in a suburban/rural type town. So I get it. I understand. I see both sides of the coin. The most, maybe not the most important, but one of the things that definitely applies to this class the most, regarding my background, is I didn't just go out and buy a Tesla and say, I'm going to start teaching a Tesla class. I have been teaching this for quite a while. I used to work for a company called Emergency Training Solutions, back in the earlier 2000s, 2010, in that era. And we would go around the area just like, I do now. And we would teach about hybrid vehicle incidents and how to deal with hybrid vehicles, because this was obviously before EVs became a thing. The guy I used to work for back then, he has since become a pretty important guy, got promoted to battalion chief at work, and he sits on the NFPA committees, a committee that writes a lot of these standards when dealing with lithium-ion issues. So he doesn't really go firehouse to firehouse anymore teaching, because he's a pretty busy guy. My company, Northeast Squad Concepts, we have kind of picked up the ball and run with it since then. So I'll give you my sales pitch right now. If anyone out there is interested in seeing the full class, we travel, we go anywhere. We do offer many other classes as well. So, feel free again to reach out. That's it for the sales pitch, no more. We'll get into the actual class. All right, so what are we going to talk about tonight? We're going to talk about hybrid vehicles. We're going to talk a little bit about plug-in hybrids, because today you're not going to see a ton of plug-in hybrids out there, but they are a technology that is starting to really pick up. Sales are starting to go through the roof on them, and we'll talk a little bit about them. And then lastly, we're going to talk about battery electric vehicles. Battery electric vehicles are obviously, probably why you're sitting in this class, because you want to learn about them, because that's what's making the news. That's what we're hearing about. So we'll talk about that. Obviously, the market has exploded over the past several years. Later on in the program, we'll talk about where we're at right now with the number of vehicles on the road and where we are going to be in just a few years. If you think you see a lot of Teslas on the road and EVs on the road now, just wait. About 2 years from now, you're going to see a whole lot more, and from companies you have literally never heard of. And we'll get into that more as well. All right, so when we are dealing with hybrids, so this is the hybrid section. I do jump back and forth a little bit between hybrids and EVs, but it'll make sense to you. It's pretty straightforward. When we're dealing with hybrid vehicle incidents, it all starts with being able to identify a vehicle as being a hybrid, an EV, or not. So, for most of you, I'm not looking to change anyone's operations. You guys respond to accidents, you guys respond to extrications. I'm sure everyone is experienced with all of that. What I'm here to do is maybe put a couple ideas in your mind of things you can add to your repertoire of what you do when you arrive on scene and when you're doing your size up operations and then initial tactics. One of them, probably the first thing that we can do as soon as we pull up from either the driver's seat or the right front seat, being the officer, is looking for specific markings that will help us tip us off that we're dealing with some sort of alternative fuel vehicle. We'll talk about what hybrid vehicle systems are. They're not all the same. They work together differently and they pose different hazards. So we're going to talk about that as well. We'll talk about response procedures again, like I said, for a whole bunch of different topics, from accidents to extrications, fires, submerged vehicles, hazmat, all of that. We'll get into, relatively quickly, all of that. So when we talk about identifying a vehicle, there's things we are going to look for. But when we do identify a vehicle as being a hybrid or an EV, for the most part, our operations are going to stay similar to what we do. But it is certainly possible that you may come across some out-of-the-box, weird type extrication situation, fire, whatever. May not be able to find the 12-volt battery, which, not to get ahead of myself, but the 12-volt system controls the flow of the high voltage system. You may need some help in locating where some of these things are, where the high voltage battery is, where do I need to avoid cutting, so on and so forth. So there is a lot of information out there right now. Every EV and hybrid has an associated ERG, or emergency response guide. Now, right now, like we said, there's dozens of models on the road. There's going to be hundreds of models of these vehicles on the road. We don't expect you to have a 3-ring binder this thick that needs to be updated every model year. That's just not a feasible thing for us to do on the street. We can use technology to our advantage, though. One of the best things that's out there right now are some of these EV apps. You can download them on your phone. I'm a big fan of EV Rescue. I think it's free for like 2 weeks. Then it becomes like, I think it's $20 a year. For those of you that carry tablets in your apparatus, for $20 a year, put it on there. It gives you access to every ERG for pretty much every vehicle on the road in the United States that is out there. It's automatically updated, so you don't have to worry about, a new model year is coming out. It's there. It's going to update itself. So it gives you that access. So for that out-of-the-box weird extrication that you need some information on, there it is. Again, is it feasible? 2 a.m, someone's trapped in the car, they're dying, we got to get them out. Yeah, we probably won't whip out the phone to start looking things up, but there is a time and a place where it may be useful. All right, so let's talk about what a hybrid vehicle is. So a hybrid vehicle uses 2 different types of technology. It is going to use an internal combustion engine that probably burns gasoline, that we've been dealing with since the beginning of time, and then it's going to use an electric motor. And how those 2 systems work together, it depends. It depends how it is, and we're going to talk about what those different systems are. In the early years, when I was teaching for Emergency Training Solutions, 15-ish, whatever it was, 20 years ago, however long it's been, there was a limited number of these vehicles on the road. So back then, we would teach make and model specific tactics. You come across a Toyota Prius, here's what you do. You come across a Honda Insight, here's what you do. We can't do that anymore because no one is going to memorize the dozens, soon to be hundreds of models that are on the road in the United States. So we have shifted our teaching style to a more generic, fully encompassing kind of delivery, where if you follow the steps that we're going to outline tonight, you should have a successful outcome at the end of the incident. A couple myths about hybrids. So, number 1, hybrid vehicles are a fad. That was something that people did think 15 years ago. They're like, this is just the next thing. Gasoline's going to go back down to $1 a gallon. This will go away, and that's that. Nobody believes that anymore. These things are here to stay. Gasoline's never going back to $1 a gallon. I hate to burst anyone's bubble. I wish it would, but it's not. And there is a strong political backing pushing these forward. Like it or not, agree with it or don't agree with it, there's a very strong political backing pushing this stuff forward. So it is not going away. Number 2, the battery will leak a significant amount of fluid if it is damaged. I'm going to jump a little bit ahead of myself. There's 2 battery technologies when we deal with this. There's nickel metal hydride, which is old school, like pre-2010, and then there's lithium ion, which is the new stuff. Nickel metal hydride is a dry or gel cell. Even if you completely had a catastrophic failure of the batteries, you're going to get a very limited, if any, electrolyte coming out. Lithium ion has a liquid electrolyte, but when most people think batteries, they think back to like a lead acid battery, where you crack it open and the fluid's coming down, and it's all over the place. You don't want to get it on yourself, etc. That's not what these are about. That being said, if you do get electrolyte that comes out, or coolant, because these lithium ions have to be cooled, coolant that is potentially contaminated with lithium ion electrolyte, it does need to be dealt with. We're not just going to throw speedy dry on it and leave it and call it a day. We do need to pass the buck to whoever your hazardous material agency is that, you know, is above the fire department, or unless your fire department runs a hazmat team. But I'm getting ahead of myself. We'll get there. Number 3, you'll get electrocuted if the hybrid is in water, or if the hybrid has been involved in an accident. And this goes for EVs as well. The answer is no, you're not. These are not earth grounded systems. If the vehicle is in water, or even if it's been involved in an accident, you can do your normal fire department operations. Can you get electrocuted with these from doing something particularly stupid? Yeah. If I take my Halligan bar and I spike the high voltage battery pack, yeah, I might get electrocuted. If I take a partner saw and I decide to cut open the high voltage battery pack, yeah, I could get electrocuted potentially. But if we stick with our normal operating procedures for accidents, extrications, and so on, there is not an electrocution hazard. It's difficult to disable the high voltage system. That is not true. The high voltage system is controlled by the low voltage or 12 volt system that we've been dealing with forever. There are multiple ways to shut down the flow of high voltage, which we'll get into. It is not difficult. Vehicle extrications are greatly hampered by high voltage wiring. So that is a myth, but it is starting to become a little bit more of a truth. And a lot of it has to do with the location of the high voltage battery packs. The hybrids, you're typically going to find the battery packs towards the rear of the vehicle, between the back seat and the trunk, or in the cargo area in an SUV, and the wiring is run on the undercarriage. For your standard doors, roof, dash extrication, it's really not a big player. But when we start talking about EVs, any of you that know where the location of the batteries are on an electric vehicle, it's the entire floor pan, essentially. The rockers, the very outermost, not so much, but the entire floor pan from axle to axle, side to side, is high voltage battery. So now any technique that involves pushing off the floor pan is out for us. Because if we do happen to penetrate the floor pan, let's say with a set of spreaders trying to get a dashboard off somebody, really bad things can happen. We can damage the batteries, causing them to go into thermal runaway, which I will explain what that is. Essentially, it's a fire that we cannot pull out and that put out, and that is all happening with somebody trapped in the car. So not a good mix of things. So anything pushing off the floor pan is out. And then lastly, special equipment is needed for fighting hybrid or EV fires. Water is still our weapon of choice. The only way to extinguish these is by cooling the battery pack. That being said, tactics have shifted. When I was teaching this class a year ago, it was all about offensive attack, lots of water, call lots of tankers if you're in a rural water supply area, and pretty much write the rest of your day off, because this is going to be like an all-day event where you need tens of thousands of gallons of water. The thought process now is, if there is no life safety hazard, if there is no exposure issues, if there's a whole bunch of other check boxes that we can make, which again, we'll talk about towards the end, let this thing burn. Let it burn, let it consume itself. It's going to make things much safer. Dry chem does not work. Dry powder does not work. Foam does not work. Foam excludes atmospheric oxygen. If you had a puddle of gasoline on fire and you put foam on it, what does it do? It excludes the atmospheric oxygen. Lithium ion batteries do not require atmospheric oxygen to burn. They are self-oxidizing. So foam will not put that fire out. How do we identify these? So I'd mentioned the first step in this whole process is being able to identify a vehicle as being a hybrid or EV. We like to break them down into formal methods and informal methods. Formal methods are things that say hybrid. It literally says the word hybrid or hybrid synergy drive or integrated motor assist, whatever the slogan the company uses. And then informal methods are things that make it a hybrid. And we'll go quickly through all of these. The exterior symbols that say hybrid, you know, on the quarter panel, on the trunk, that's where we can look for them. But these are plastic pressed and glued on emblems, which, number one, some people like to debadge their vehicles, or if this thing is wrapped around a tree, or if it's rolled over on a highway, they may or may not be visible. So we can't rely on that solely as being our only way of being able to identify. Take a look at the instrument cluster. You walk up to the car, you make your patient contact, look at the instrument cluster. If anyone's driven a Tesla, anybody, in the audience who has driven a Tesla before knows that there is no dashboard. It's a little iPad looking device next to you, which takes a lot of getting used to. But if you see something like that where there is no dashboard, that can kind of tip you off. This isn't normal. Look for the word hybrid, though. You may see some weird computer schematic showing if power is coming out of the high voltage battery or going back into the high voltage battery. All these are giveaways that you can look for when you make your patient contact. If you can get the hood open, take a look at the hood. There's usually a shroud that says the word hybrid or something along those lines on it. And then your informal methods. Number one, battery vents. So, these are hybrids. We're not plugging these things in. They charge and discharge as we drive around. And obviously, as you charge and discharge a battery, it creates heat. That heat's got to go somewhere. Maybe not that apparent, maybe not that obvious where they are, little slits in the glass. Or if you look at the middle picture, those could easily be mistaken for speakers. The picture all the way on the left, they're behind the headrest. So at first glance, as we walk up, easy thing to miss. If you look at that instrument cluster, you may see weird gauges that you're not used to seeing, a charge assist indicator. You see that, this isn't normal. This is not a regular gasoline car. So looking for things out of the normal like that. One thing that used to be the dead giveaway that you were dealing with a hybrid is the auto stop feature, where car comes to a red light, gasoline engine shuts itself off. A couple different ways you would see this. The needle on the tach would go below 0 to an auto stop feature like you see in the picture, or you might have a light flashing on and off that says ready or auto stop. As soon as you take your foot off the brake, car restarts, off you go. But that used to be really good. You would always say, okay, I got it. It's a hybrid. It says auto stop on it. That's not the case anymore. Everybody knows that pretty much probably 80% of gasoline powered vehicles on the road right now have that feature in them. So we can't use that alone, again, to identify it. It's a tip, it's a clue, but may not be it. What is the dead giveaway is the orange high voltage cables. So there is not a lot of standardization in this industry of hybrids and EVs. But one thing that is standardized is that the high voltage cables are colored orange. If you see one of these, you're dealing with a hybrid or an EV. You're going to hear me say this a bunch tonight. When you come across these wires, these orange high voltage cables, we do not touch, cut, disassemble, or in any way come in contact with them. The reason being, these are not, it's not like sticking a fork in your outlet at home where you receive obviously it could kill you, but you receive a shock and you're like, oh, I won't do that again. This is enough voltage and amperage to kill you where you stand. So we do not want to make that mistake. Even if I am 100% sure I followed all my shutdown procedures that we're going to go over, I did them perfectly the way I was taught to, things go wrong. If we do low voltage shutdowns, we're relying on a relay to open, which relays don't always work. So we treat these as if they're live. It's basically like going to a wires down call, finding a primary line down in the street. If I'm positive that thing doesn't have power, I'm still not touching it. Treat these the same way. You'll find these cables run typically on the underside of the vehicle. It could be the driver's side, could be the passenger side, could be somewhere down the middle. And they do cover them up quite a bit. They run them in conduits where you may or may not be able to see them. Take a look at the body shape. A good giveaway that you're dealing with an EV is the fact that there's very limited or no grill or air vents in the front. There's really no motor for it to cool. And then take a walk around the back. If there's no tailpipe, EVs do not have tailpipes. That's another good giveaway that you're dealing with an electric vehicle. All right, what makes a hybrid a hybrid? So there's 5 components to it. There's a gasoline engine, there's an electric motor, and there's high voltage batteries. And then there's the electrical system that ties the electric motor into the high voltage batteries. Those are 4 of the 5 components. The 5th component is probably the most important one, and that is the safety design features, also known as a battery management system. That is what makes or breaks the vehicle, the toy, the micro mobility device. That's what makes or breaks it from catching on fire or not. To date, to the best of my knowledge, there have been 0 Tesla fires that were not secondary to some sort of mechanical damage, some sort of accident or damage to the battery pack. And the reason for that is Tesla uses the gold standard of battery management systems. In the heading of lithium ion, there are many chemical compounds. Some are more stable than others, some are more energy dense than others. Tesla actually uses one of the least stable compounds, but the reason they're not catching on fire left and right, or pretty much at all if they're not damaged, is because of their battery management system. And that is the reason why you are seeing these scooters and these e-bikes and hoverboards, why they are catching on fire. Most of them are not made in this country. Most of them have not been through UL testing, even though a pretty shady thing they do is they put UL stickers on them to make you think that they've been through testing, but they haven't. And they lack quality safety design features, which is why these things are burning on a very regular basis. The layout of these vehicles, like I said, typically the high voltage battery pack is somewhere in the rear. In a sedan, it's typically between the back seats and the trunk. You'll see the high voltage wiring on the top of that picture running to an electric motor. You may find one or two electric motors. You may find one for the front axle, one for the rear axle. And the newest technology is an electric motor driving each wheel. Not overly important to us, but it does mean more wiring all over the place. The 12-volt battery is what controls the flow of that electricity, and we do want to find that early. Sometimes finding the 12-volt battery is a challenge in and of itself because they are not always under the hood like we're used to. And you're going to have gasoline lines that are going to be run probably somewhat remote from the high voltage lines. You're not going to find them right next to each other. They might not be as separated as you see in that picture, but you're going to find them somewhat remote. To flip into EVs really quick for one slide, this is where the high voltage batteries are on an electric vehicle. This is a Tesla specifically, but you can see it's 7,000 individual cells, axle to axle, side to side. That's where the majority of the weight of this vehicle is. And this is why we cannot push off of anything involving the floorboard. But we're going to talk about workarounds for that in a little bit. All right, so the electric motor, what does it do? Besides propelling the car down the road, it does a few other things. It steals energy or electricity from the gasoline engine and charges the battery. Because remember, these things have to charge while they're driving. And then it does a second thing that charges the battery. It does what is called regenerative braking. Anyone who's driven a Tesla, you can find out very shortly that when you take your foot off the accelerator, the car brings itself to it brings itself to a stop. It brakes on its own. It's like driving a fire truck with like your Jake brake on high and your transmission retarder on. It's a very aggressive braking. There's different levels you can set it to, but it's a very aggressive braking. It actually makes your brake lights come on and it brings the car to a stop. The only time you really touch the service brakes or the actual brakes in this car is if someone cuts you off or you come into an intersection a little hot or light changes on you unexpectedly, whatever. Other than that, you're using regenerative braking to stop. And what that is, what regenerative braking is, it's simply, to keep it nice and simple, it spins the electric motor backwards and it sends electricity back into the high voltage battery. So the key to controlling high voltage flow, I already gave it away, finding that 12-volt battery. But, so you think, okay, we got to get the 12-volt battery, got to disconnect it. There are a few things that we should try and take care of or take advantage of before we take that power away. If we can power seats back, if we can open doors, because most modern EVs require 12-volt power to use the exterior door handle to actually open the door. And if I can roll windows down. Most modern vehicles now are being produced with laminated safety glass all the way around. So what that means to me is if I need to take glass out for an extrication, my spring-loaded center punch isn't doing it anymore. I now have to get my Glassmaster, my Sawzall, whatever, and actually physically cut that window out. Why is that a problem? Because what are extrications all about? Saving time and getting the patient to that hospital as soon as possible. If I'm wasting time cutting glass when I could have just hit the down button while I still had 12-volt power, that would have been a huge time savings. Also, on the other side, though, why we do want to take it away, besides the high voltage power, is that the supplemental restraining systems, the airbags, are controlled by 12-volt power. And we want to give those time to de-energize them and have the capacitors drain down. So it's kind of a happy medium. You got to get to it quickly, find where it is, take care of what you have to take care of with 12-volt power, and then remove it immediately when you're done taking advantage of it. The two different technologies that I had mentioned already, nickel metal hydride. It's a stable, relatively stable compound, but it is not nearly as energy dense as lithium ion. Lithium ion is what you're going to find in anything modern, anything. So I know it's a broad range, but the changeover in the industry was anywhere between 2010 and 2015. So anything made newer than 2015 is almost 100% going to be lithium ion powered. Anything before 2010, more than likely nickel metal hydride. You just have that gray area in between. The lithium ion is obviously much more prone to fire, and it will burn for quite a while. And there is a huge, huge reignition hazard, which we're going to talk about. The voltages in these high voltage batteries, both for hybrids and EVs, you're in the mid 100s to like mid 300 range for most of them. And then you have boost converters in many of these vehicles that then boost those voltages, sometimes up to over 600 volts. And you can find them in DC or AC, depending on what the engineers designed their motors to be powered by. They can, invert it, the DC to an AC power. They do whatever they need to do. So we have the hazards of that very, very high voltage. In terms of shutdown, so how can we make this vehicle safe for us? Option number one, the simple act of taking the key, turning it to the off position, and pulling it out of the ignition. That alone, when everything is working properly, and that is the key to this whole story, when everything is working properly, when you pull that key out, the relays will open and stop the flow of high voltage. Here's the issue. How many of you guys out there have an actual physical key in your car anymore? Most modern vehicles do not have a physical key. Everything has moved to a fob, or if anyone's familiar with really modern vehicles, how do I drive the Tesla? Cell phone. Everything is via app on the cell phone. So we are not going to be able to get into someone's cell phone and shut things down, or lean in and start playing with the tablet on there to try and figure out what the shutdown is. So yes, this is an option, but it is becoming less of an option as more modern vehicles roll out. They're not putting keys in them anymore. So we need other ways of shutting it down. 12-volt battery, if we can find it, which the ERGs are hugely helpful for finding them. If we do find them, we want to either disconnect or what we call double cut the negative side. Our rule of thumb at work is, a minor accident, we take the time to actually get the wrench set out and disconnect it properly, do the driver a solid and don't mess his car up worse than it already is. But major MVAs, extrications, we're not taking the time. We are going to double cut, meaning taking a section out of that negative wire to assure that it's not going to come in contact. Look also for multiple wires coming off of it. I'm going to talk a little bit about an extrication I had at work where we had to cut a Tesla, and we missed the fact that there was a grounding strap coming off the side of the battery. We missed it when we cut it, and then we were wondering, well, why is everything 12 volts still powered? That was one of the reasons why. So take the time, take a look, and make sure you cut everything. Third option, they have contacts that you can pull directly out. They're typically in a box with a plastic cover mounted somewhere near the firewall. Pull the cover off, you'll see a bunch of different, they look like a bunch of relays, but when you pull those contacts, they will open the actual relays in the battery pack. One of those controls the flow of high voltage. I don't know which one. I don't have the time to look it up. So what's the answer? We pull all of them out because one of them will open those relays for that high voltage power. The more modern version of those contacts that we can pull is what is called the first responder loop. You will find these in most EVs on the road today. What it is a piece of relatively small gauge wire, and they put, well, Tesla anyway, puts red split loom over it and an orange tag. On the orange tag, it's got a picture of a fire helmet, a picture of shears, and a dotted line with an arrow. So it's saying, hey, dumb fireman, cut here. That is one of our shutdown procedures, and we absolutely want to make sure we do cut that, because I went to another Tesla accident right in front of the firehouse about 2 weeks ago, and we learned that the low voltage system is actually backfed from the high voltage system through a step down transformer. So if you do cut the battery, but you don't cut the first responder loop, everything 12 volt is still powered. Now that was the case for that specific car. That was a Tesla Model Y. I'm not saying that's the same for everything because there is really no standardization, but for that specific vehicle, just do yourself a favor and take both if you're looking to cut power. They are not all in red split loom. Ford Mustang, for instance, they kind of bury it deep in the engine and it's in black split loom, so you have to do a little searching to see where it's at. But this is another option you're going to find in all EVs, and very simple, easy way to do it. Also, they typically put these in 2 locations. So Tesla puts one under the front, under the hood, which they call the frunk, which I hate using that word, but they put it under the hood. But if that vehicle underrode a tractor trailer, they actually put a second one in the rear deck. It's, again, no standardization. Don't know which side it's on. Some are on the driver's side, some are on the passenger side. ERG is going to tell you. Other than that, you're going to have to kind of hunt around and look yourself. And then the last option. So every way we just talked about, key, 12-volt battery, the contacts in the box, and the first responder loop. All 4 of those are low voltage disconnects. They all require that when you disconnect them, cut them, whatever, they all require a relay to open to do what they were supposed to do. We all know relays malfunction. They may get stuck closed, they may get fused closed in a fire, whatever the case may be. So we can't guarantee that we have truly cut high voltage power. This last option is a true high voltage disconnect. You are removing the contacts directly from the battery, but it comes with a downside. The downside is if something is drawing energy out of that battery and you pull these contacts, you have an arc hazard. When these vehicles go to the shop, go to the mechanic for work, and they have to pull these, the mechanics wear rated, tested, high voltage gloves. We don't have those. I don't think any fire department carries those. So is it safe for us to pull this? I can't say yes. I can't say no. I'm going to just do the CYA answer and say consult the ERG. Because to be honest with you, some manufacturers say go ahead and pull it. Others tell you absolutely do not pull it. And then the third companies will say they won't say anything about it in the ERG. They won't even address it. So my personal opinion on it is it's the bottom of our hierarchy of how we're going to disconnect power because there is a big hazard associated with it. The style in the picture here, it's a 3-position switch. This is the style you often find in SUVs. You just give it a little quarter turn, pull straight out. If you can see on the picture, it says lock, unlock, and service. So just quarter turn, pull straight out, and that's how it comes out. There are other styles as well, but we're not going to get into all the different styles. All right, how do the gasoline engine and the electric motor work together? So in a full hybrid, the vehicle can operate on the electric motor alone, meaning typically 0 to 15 miles an hour, it's on the electric motor. Why is that a hazard to us? Because when we pull up on scene of an accident and I'm, let's say, doing a 360, walking around the front of that car, it could be in drive, ready to move at a moment's notice with 0 audible warning. If you pulled up to a regular gasoline car that had been involved in an accident, you hear the motor running, it gives you the audible cue to tell the driver, hey, make sure that car's in park, turn it off. With these, it is easy to look past that and forget to tell them, is your vehicle off? Is it in park? And we have that hazard of what we call it the unexpected movement hazard. Mild hybrids, the gasoline engine and the electric motor always work together. So you're like, okay, great. I'll hear that that gasoline motor running when I pull up on scene. Not necessarily true. These are the ones that often come to a stop or the gasoline motor shuts down at a red light. So as soon as they take their foot off the brake, touch the accelerator, gasoline engine instantly restarts and the vehicle can move. And it's still in drive the whole time for, that can all happen with the vehicle in drive. So we still have that problem. How do we overcome it? We'll talk about that in a minute. Plug-in electric vehicles, like I said, they are not overly popular, but they are very quickly gaining popularity. How they work, you get a small amount of mileage battery alone. So essentially, they are an EV for the first 40 or 50 miles of travel. Then after that, once we deplete the high voltage battery, it kicks over to a gasoline-powered car and goes the rest of the way on gasoline until you run out of gasoline or plug the car back in. Many manufacturers are starting to come out with these. You're going to see a lot more of these on the road over the next few years. We talked a little bit about lithium-ion batteries. They're high power to weight ratio, very energy efficient. They're what's out there now, but there's big downsides to it. They do not do well with temperature extremes. And there are many reasons they may fail. One of the key reasons they may fail is puncture. So if you think about a Tesla or any EV, the batteries are on the undercarriage. Anyone's driven down the highway and seen debris on the side of the road, a big piece of metal kicks up underneath, punctures the battery pack, easily cause those battery cells to be damaged, leading to thermal runaway, leading to a fire. Overcharging, overheating, short circuits. This is what we're finding a lot with the micromobility devices. that is leading to those fires. So the unexpected movement hazard, we talked about what it is, why it happens. How can we deal with it? I had mentioned in the beginning, that I just want to add a few steps to your repertoire of what you do with these accidents. The first one being looking for those identifying factors. Here's the second one. During our size up, during our walk up to the car, as we're about to make patient contact, chock the wheels as you approach that car. We can do it with 4x4s. We can do it with wheel chocks, whatever. Something front and back of a tire. So it can't go forward, it can't go reverse. If we can do that, we take away that unexpected movement hazard. There's other ways of doing it as well. There's aftermarket devices you can purchase, which we'll talk about later on, but that's going to be our easiest, cheapest way of doing it. 4x4, front and back, that's that. Having placed the vehicle in park, remove the key from the ignition or shut it down. All right, so let's talk quickly about some response procedures for all these different events. So do your size up for accidents, looking for your gasoline leaks, your fluids on the ground, power lines down, number of patients, ejected people, but do your formal and informal method checks as well. Start it from when you pull up and then continue it as you walk up. Chock those wheels, just like in that picture, front and back of a single tire. Then get the vehicle in park. Getting the vehicle in park can be tricky. It is not as straightforward anymore as what's in that picture. And we'll talk about some of the different options that are out there. And then set the parking brake if there is one. Most of these new EVs do not have a manual or separate parking brake. They're electromagnetically held in place that when you put the vehicle in park, it automatically applies that parking brake. But if they have one, have them apply it. How do we shift this thing in the park? A couple different options we have. Teslas, generally, not all the same, but they have a push button at the end of the shift stalk. The two vehicles on the right aren't even EVs or hybrids. They're just modern vehicles. The Ram 1500, that knob easily could be mistaken for a volume knob or something to control your HVAC. The bottom left is a Prius. The right one is the new Chevy Tahoe, which is just weird. The park and the neutral are push buttons. The reverse and drive, you kind of flip towards you. It's not something, it's not intuitive. It's not something you may be used to seeing. So if your driver or occupant is conscious, alert, and oriented, hey, use them to your advantage. Have them put it in park. The other reason it is so important to chock the front and back of the wheels is with these modern EVs, everything requires 12-volt power, from opening the door to rolling the windows to popping the hood to putting it in park. If 12 volts was lost, whether it was a fire or an accident or the battery just died, whatever the case is, the vehicle could enter what is called a free roll position, where the car is now at the mercy of the grade of the land. So if it's relatively level and you put a little pressure on it, not thinking, that car may just go rolling down. Not a good look to be having a car rolling down a hill with a patient inside, or if it's on fire. So another very good reason to chock the front and back of a tire to take away the possibility of it moving if it is in free roll. All right, so for shutdown, we talked about the individual methods. We always want to take one method and back it up with another. So option one, take that key out, or if it's a fob, hit the off button and then get the fob out of the vehicle. And we're going to back that up with disconnecting that 12-volt battery, because that 12-volt battery, like we said, controls a lot of other things as well. Option number two, if it's a cell phone controlled, or we can't get to the fob, or the guy's pinned up against the dash and we can't get in there, get to that 12-volt battery, disconnect it, or find those contacts, or find that first responder loop, cut them. That's the best we can do. It's still going to do the same thing for us. If we do have damaged batteries or visible high voltage cables, do not touch them. Stay away. Let everyone know so nobody comes in contact with them. Key fobs are what most vehicles have. Tesla doesn't necessarily have to run their car off an app. It does come with what looks like a credit card. If they do have a fob, what we want to do is make sure it is in the vehicle during the shutdown process, and then we get it out of the vehicle once the shutdown process is done. And you might think I'm nuts, but the rule of thumb is 16 feet away. A lot of the old school key fobs could communicate for a longer distance than the modern ones are pretty good. As soon as you're out of the vehicle, they know you're out of the vehicle and you can't control things. Older ones were further. So the rule of thumb is a 16-foot distance. Bottom line is get it out of the vehicle, get it away. There's about 12 manufacturers right now that are running cars that can be controlled by an app. All the way to the point of Tesla has self-driving cars with your app. So you could stand across a parking lot with your app open and actually have your car drive to you if you purchase that package. which does that really apply to us? Maybe, maybe not, but it's just the direction we're going. Things are crazy. You're not going to be able to unlock someone's phone, and you're probably not going to know how to use their app. So this as a shutdown method, probably not applicable to us. Vehicle accidents with extrications. So in terms of vehicle stabilization, for your standard doors, roof, dash removal, take a peek. Most places still apply step chocks, maybe in 4 spots. Take a peek real quick, make sure that there's no exposed high voltage wiring, but normally your standard crib points are perfectly acceptable. But for out of the box stuff, this is where it gets a little tricky. The picture on the left, if you had to get into that passenger compartment of the bottom car, if this was a hybrid, if I stabilized that top car, or if there wasn't a top car, maybe an underroad a tractor trailer, maybe tunneling from the rear would be something I would normally do. Tunneling is not a great idea because that would involve climbing over a potentially damaged high voltage battery pack. So we need to start thinking about other game plans. A lot of these game plans may involve controlled movements of cars using grip hoists, maybe winches. I'm not a huge winch fan for moving cars with people inside. Grip hoists are much more controlled, but something to move that car to a position where we can extricate. And then the picture on the right, a much more common scenario, a rolled over vehicle where we have to stabilize it. So we know that the bottom of an EV, the whole floor pan is high voltage batteries. So it is definitely important to take note of where we put the heads of our struts and where we tie back. We do a lot of extrication classes, my training company. We do a lot of extrication classes every year, and we just teach all way. We don't go around preaching this is the way to do it. We just teach all way, but one of the ways we find very, very useful for side resting is this reverse tension buttress tie back system, because it leaves the entire clean side or top side of the car wide open to do all the cutting you want to do. There's no struts in the way. You can do everything from stabilizing from the dirty side. But with how Teslas are designed, you need to be very careful of where you can tie into and where we're going to be placing our struts. So maybe we can do it, maybe we can't. There's no easy answer for a lot of this, but it's something we can look for. You got something, Charlie? I think your audio's off. Charlie, I think your audio's off.
Okay. There was a question about one of the previous slides,
Yep.
not to touch damaged or broken orange cables.
Yes.
I thought somebody said, I thought it was said not to touch them at all. I don't understand. I'm not sure I understand the question, but maybe we clarify it.
So, I mean, we are not touching high voltage cables, whether they're damaged, whether they're broken, whether they're intact. Yeah, I'll just try and make that a little more clear. Yes, we are not touching high voltage cables, no matter what the circumstances are.
I hope that answers the question. All right.
Anything else?
That's the only thing that came up on a slide
Okay.
that I could see.
Okay.
Thank you.
Another technique that we teach for getting dashboards off of people. You can obviously stick with your old school stuff, nothing wrong with that, but we like the no cut dash lift, meaning you don't need to make any relief cuts. What you're attacking is called the transverse dash bar. It is typically a round steel tube that goes A pillar to A pillar, and it's tied down usually on the transmission hump by a couple either flat steel piece of metal or maybe even some nylon straps, whatever the case is. They're not all the same. They're not always round. Some are tubular or some are rectangular, some are square, whatever. But when you attack that bar, everything in that dashboard that is significant is tied into that bar. So the steering column, the airbags, there's some usually large pieces of metal. When you can attack that and break it free from its mounts, it will bring the entire dashboard up off your victim with no relief cuts, which I've done it successfully, I think 4 times now in the real world. We do it in training. Again, it's not the answer for everything, but it certainly works well. But here's the problem. The picture you see here is a little deceiving. The car's on its side and we're using a ram. On a regular vehicle, I like to use spreaders, get myself between the driver and passenger, get in the back seat, sneak myself through the middle, stick the tips of the spreaders where the change drawer is, open and close. Usually by your 3rd attempt, you'll break a bunch of plastic, get in deep enough, and come in contact with it. You'll see what I'm talking about here.
Pose them all the way. So you don't, yeah, just pose them all the way. Yeah, there you go. Oh, yeah.
Huge lift with minimal time, minimal tool usage, minimal cut time. But here's the problem. If this was a Tesla, we cannot push off the floor pan like that, because God forbid we penetrate that battery case, cause the batteries to go and thermal runaway with somebody trapped. This is the workaround. We can do the same technique, but off of the rockers. If you remember back to that Tesla picture, it shows that the rockers are safe stabilization, lifting, and pushing off of areas. There is no high voltage batteries on the very edges. And that's enough lift. Typically, when we try and get a dashboard off someone, what do you need? An inch or two? And that's going to easily gain you that. Ultra high strength steel is something that we all are dealing with, whether it's a standard gasoline car or something alternative. The tensile strengths in these posts, specifically B posts, are really, really tough to deal with. We have brand new Pantheon Homatro tools at work, and even they have struggled to cut some of the metals out there. The picture on the right is a Land Rover that I cut a couple weeks ago, and it was tough. With these wide posts too, wide posts are difficult because our cutters can't get all the way around them. Back in the day, we would probably take a wide post, crush it with spreaders so we could get our cutters around. The way the ultra high strength steels work is when you crush it, you're actually making it stronger, and you're making life for your cutters even more difficult. The workaround is that these high strength steels, although they resist being cut, they tear relatively easily. So if you can get a cut in there and then put your spreaders where that cut was made, spread that cut, it will tear free often quicker than if we tried cutting it over and over. All right, vehicle fires. So for a hybrid vehicle, because the battery is in the back, sedans, we snip the trunk lid off. You have direct access to put water on the batteries. SUVs, the whole cargo area is battery. So again, you have direct access to put water. When we talk about why these issues are occurring in these EVs, it's because we can't get water where it needs to go. It's really nothing more than we just can't apply the water where it needs to go. But with a hybrid, because the battery is relatively exposed, when we get the trunk out of the way or the rear hatch open, we can do an offensive fire attack. Prepare to be there a while, prepare to have a lot of water supply on the way if you're in a rural area, or hook up to a hydrant in a more urban area. Evacuate the area bystanders. What comes out of this smoke is so bad. We're going to go through a few of the products of combustion. It's so bad for you. Stuff that could literally kill you where you are, and stuff that'll give you cancer 20 years from now. We don't want to mess around with that. So get the bystanders out and wear your SCBA. Most of this we already covered. The third bullet point there. The battery not just may reignite after initial extinguishment, it almost definitely will. It will probably reignite during extinguishment efforts. It will probably reignite post-fire control while you're still on scene. And it has the potential to reignite hours, maybe even days or weeks later. So it is something to talk to your tow companies about. The batteries are cooled with often a blue coolant. So if you see a blue coolant coming out of the battery pack after an accident, that's indicating that there's been damage to the battery pack, and we need to watch out for the potential for thermal runaway, etc. There are UN numbers for this stuff, so it is in the DOT guide. All right, so if you pull up to this incident right here, that car needs to get removed from that garage as soon as humanly possible. This is a structure fire. We need a line on the car and a line in that building. Lithium-ion batteries burn at about 2,800 degrees. If we do not separate that car from that house, one way or the other, a winch, a chain to another vehicle, something, we're going to lose the battle, because we are fighting a fire that's burning at 2,800 degrees that we can't get water where it needs to go. When you pull up to one of these, one of the first things we need to try and determine, is it a hybrid or an EV? Because that is going to determine where we apply our water. If it's a hybrid, we can apply water through the trunk in the back. If it's an EV, it's the whole undercarriage, and we have our work cut out for us. Next, if we can find the owner, ask them what year their car is. Hopefully they have an answer for you, Because if it's older, pre-2010, like we said, nickel metal hydride. If it's newer, lithium ion. And then we definitely have our work cut out for us. Chalk the wheels, as we don't want it rolling away on us on fire. Please wear your SCBA. I am the last guy to be preaching like always wear your SCBA, blah, blah, don't ever breathe. I'm the last guy should be preaching that. But with these, we are not messing around. It is serious stuff that comes out of this. The water runoff after a car fire. So we all go to car fires and we probably don't, probably pay much attention to the water runoff. The water runoff with these, the more studies they've been doing, they've been finding that it's not as bad as was initially thought. A lot of the reason is because we just dump so much water on them. It's diluting a lot of the chemicals, but it needs to be dealt with. You get a car fire involving a lithium ion powered vehicle, notify. It's a hazmat situation, so notify whoever you need to notify for hazardous materials. A lot of what you see coming off this car, it looks like smoke. A lot of it is gases escaping the individual cells, which is ridiculously flammable. Do not put your body in that area, because what appears to be steam or smoke now will turn to fire with not enough time for you to react to get yourself out of there. High voltage battery breaches, if you do get electrolyte out, make sure you contact whoever it is you need to contact. For us in Connecticut, we get the DEEP involved to come out, and they want to be involved and they want to know about this stuff. For you guys, whoever your hazmat team is, get them out there because they need to be aware of this. Deal with the water runoff or deal with the battery cells, so on and so forth. Submerged vehicles. After Hurricane Ian, down in Florida, they had, I believe, 11 documented cases of EVs catching on fire when the floodwaters went away. There's stories of many, many more, but there's 11 documented. And then the most recent hurricane down there, I think it was Idalia. Again, they had a bunch of EVs catch on fire. But for your run-of-the-mill submerged vehicle, you can operate safely in and around a submerged electric or hybrid vehicle. You can do your extrication. You can do your patient care. Do what you have to do to safely remove people. You may see what's called micro bubbling. It's a little bit of water reacting with the lithium ion. I wouldn't stand in it just because I probably wouldn't want to do that, but it is not a hazard to you. If you consult the ERGs, everybody agrees with what I just said, except Ford. The Ford F-150 Lightning actually tells you that you are supposed to leave a vehicle in the water until high voltage has been removed from the battery. The bad news is you cannot remove high voltage from the battery. Engineers can't even do it. So if you got someone trapped in the car, we have a job to do. We're not going to tell the guy, sorry, dude, like you're stuck in the car and we can't help you. Ford is saying this. The consensus is it's a CYA kind of thing, because if someone did happen to get electrocuted from doing something stupid, Ford's going to tell you, well, you shouldn't have been there. We told you not to be in there. Tesla and everyone else says you have no greater risk of electrocution or shock because the vehicle is in water. Do what you have to do with the vehicle in water. Just do your normal procedures. All right, in terms of EVs. So we'll move through EVs. What time we got? All right, we'll try and get through this relatively quickly. Sorry to go over the hour.
No, you're doing good. You're doing good. There's a lot of information here. That's good.
All right. EVs have a lot of the same hazards as hybrids. You get a range with these batteries, and the range they advertise does not equate to real life. I can tell you that honestly from driving this car for the last year and a half or so. It's significantly less. A lot of, especially with the older ones, like I drive a 2019, you are not supposed to charge the battery to 100% or you will damage the battery. But if you don't charge to 100%, you're not getting the mileage you thought you were going to. And then God forbid it's cold out, God forbid you drive faster than 60 miles an hour, you're reducing your ability to drive significantly. Also, you're not supposed to drain the battery all the way down. If you do, you will damage the battery. So you got to knock off some off the top, knock off some off the bottom. But guess what people are going to do? They're going to drive this thing to however is going to fit their life. And a lot of them may overcharge it, and a lot of them may draw it way down. Now, with a Tesla, I'm not overly concerned about it. But with some of these newer vehicles that are going to be coming over, you may see Chinese-made EVs on the road within the next year, maybe even shorter. And another big hazard that we're starting to see is people who are making EVs themselves in their backyards. They are taking a regular gasoline-powered car, buying stuff on the internet, and converting it themselves. You start damaging those batteries, it's going to lead to a fire at some point. So where are we at right now? Right now, there's about 20 million of these vehicles on the road worldwide, 3 million in the US. But look at what is projected a little bit more than a year and something away. 77 million worldwide. That is quadrupling. Quadruple that US number, that means 12 million. I was given this class for a fire department out by the casinos in Connecticut there. And one of the guys said he just got back from vacation in California. He goes, man, you know how around here, you see a Tesla once in a while, but it's like the exception to the rule. Out there, that's all you see is EVs. If anyone remembers California and now pretty much all these states, they want to ban the sale of internal combustion engines come 2035. So it's not going away. The funny part about California is after they said that 2 weeks later, they told people to stop charging their EVs because the infrastructure couldn't handle it. So there's going to be a lot of bumps along the way. Worldwide, 370 models, that's coming here. You're not going to be just seeing Toyotas and Chevys and Dodges, and the world's changing. There's a company, NIO out of China. They're probably going to be the first ones with Chinese cars on the road in the US. Fiskars, Lucids, Rivians, you name it, it's coming. So it is a trend that is definitely not going away. So here's the issue. This is the battery pack out of a Tesla Model 3, 7,000 individual cells. They break them up into modules, and the modules are they're broken up by structural steel, and each individual cell is epoxied in place. So you can't picture this as, oh, I'll just breach the battery pack, fill it up with water, and the fire will go out. That's not how this works. You will not be able to identify where the problem area is with this. Eventually, during thermal runaway, you'll get horizontal shooting flames out of this battery pack once the steel case melts. But initially, until that happens, and by the time that happens, most of that battery is already in thermal runaway. There's no easy answer to how to put these things out. Currently, they're using the 18650 battery in most of the vehicles out there, especially Teslas. They're shifting to a 4680, which will reduce the number of batteries from 7,000 to about 2,000. But the downside is when one of these larger ones goes into thermal runaway, you are going to know it because they are so energy dense. It is ridiculous. They are going to burn so hot and so fiercely and for a long extended period. It's going to be interesting. Most of this we have covered. The lithium production is supposed to increase, but we all know lithium comes from, third world countries, child labor. It's not a good look for the people who want to see this stuff succeed. So there is other technologies in the works. They're looking at sodium ion. For those of us who like going to fires, good news is sodium burns really well, pretty much as good as lithium. So if they do shift to sodium because it's a more readily available element out in the world, it will still burn. What they are working on, and I just got some new intel Monday night about this. They are working on solid state batteries, which I knew this, but everything I've read said it's many years away, like probably 10 years plus before the technology is there. A car manufacturer came out and said that they will have a solid state battery on the road within 4 years. So that may be a game changer. It will take away a lot of these issues, but we'll see it when it actually happens. The two key takeaways from this slide here is, like I mentioned earlier, these fires not only may, but probably will reignite hours or even days later. Those of you who have junkyards and deal with the tow companies, you need to advise them that they need to take one of these vehicles, whether it's been involved in an accident, extrication, fire, whatever, and isolate it. The rule of thumb is a 50-foot radius with no exposures around it. Exposures meaning other cars, a fence, a building, whatever. It's got to stay away. Now, most of these tow companies are not aware of this. I work pretty closely with a couple of tow companies for our extrication classes, and those guys are really not aware of the hazards associated with it. Now, that might not be possible, that 50-foot radius. The city I work in is a very dense urban city. They don't have these junkyards or these tow yards. They'll have 20, 30, 40 vehicles there on like a postage stamp lot. We'll talk at the end of the program, something new that is starting to come to America to, I don't want to say fix that problem, but at least to be able to isolate the vehicle. It has its own issues, but there is other things in the works. But do your best to tell them they need to isolate these vehicles from everything else. I don't believe it's in this PowerPoint. I just updated a slide in my longer program yesterday. There was a car, a Tesla, that caught fire in a junkyard. It was weeks, if not months after the incident, and it burned. So this stuff is absolutely catching fire post-fire control down the road. All right, so what is thermal runaway? I know what the slide says. I'll try and explain to you, like, just how I like to explain it. Picture an individual cell. It gets damaged somehow, whether it's a puncture, whether it's overcharging, overheating, whatever. It's damaged and a short circuit takes place inside, which causes the internals of that battery to start heating up. As they heat up, that electrolyte turns into a gaseous state. The temperature continues to increase until the temperature reaches the gas's ignition temperature, and what is now off gassing now catches fire. That is thermal runaway. We, as the fire department, cannot stop thermal runaway. You can't get water to the inside of a cell. You saw what the battery pack looks like. It's just not possible. What we can stop, or at least attempt to stop, is the next step in the process, which is called propagation. Propagation is nothing more than exposure protection. Think about a building on fire with a bunch of buildings next to it. We may write off the initial fire building to protect the exposures. Same thing here. That first battery went into thermal runaway. You have adjacent cells all around it. When the first one catches fire, it starts heating up the ones next to it. They start going through the same process. The electrolyte becomes a gaseous state. It reaches its ignition temperature and it catches fire. Now, instead of one cell, you have multiple cells. And it's a self-fulfilling prophecy where all of them will catch fire if we don't do something to stop it. We can try and stop the propagation. It's going to involve a lot of time and a lot of water. This is a quick video. I won't talk over it because it's loud.
See that thing going out? That went straight in. You don't need to see that slide? That's not in the one. Yes, now I see. That's video on.
So that was a relatively small lithium-ion battery that was put on a heating plate and brought to its ignition temperature. I'm talking to guys from New York, so some of you may have actually been at that. This was down in New York City, the lithium-ion symposium last year. You saw how aggressively it burned. One of the other big things was, did you see the individual cells shooting and flying off all over the place? Somebody puts their scooter in their house to charge it, and that occurs. You could end up with not only a fire in that immediate area, but especially larger houses, big open floor plans. Those cells start shooting 50, 80, 100 feet away. You get secondary fires further away. You're going to have a very quick, rapid fire spread. In terms of what is coming out of these cars, so we all know we should wear a mask at car fires. Maybe we do, maybe we don't. But with these, we cannot mess around. In addition to everything bad coming out of it, similar to a car fire, you got volatile organic compounds, not good for you to breathe in. Hydrogen gas, heavy metals, the anode and cathode. I don't get scientific with it. This is as scientific as I'm going to get. The anode and cathode, the positive and negative sides of the battery, they use various types of heavy metals. The ones I listed, manganese, graphite, whatever, all these different products. When they break down in a fire, they become microscopic and get entrained in the smoke. Your lungs do not like breathing in manganese or nickel. Not good for you. And then the last two are some of the worst, the phosphorus pentafluoride. If anyone, you guys are, you know the whole PFAS issue, getting rid of your phone, the problem with PFAS in our gear. Phosphorus pentafluoride is like a cousin of PFAS. It will give you cancer if you breathe enough of it in at some point down the road. And then lastly is hydrogen fluoride. If you went to a hydrogen fluoride leak, let's say in an industrial facility, this would be like a big deal hazmat, like level A entry, big technical decon, a lot of manpower, big deal. Now we're essentially going to the same product in a car fire with our mask hanging around our waist, not breathing air. Not something you want to do. You breathe enough of that in, it will literally kill you where you stand. And when it heats up to a certain level, you get hydrofluoric acid. It is just not good overall. Wear your masks, please, with these. Couple quick case studies. So Stanford had a Tesla Model 3 catch fire a little bit over a year ago. Guy was driving, parked his car, caught fire. The investigators later on, the DEP actually investigates for us these things. A guy I was teaching a class to for his volunteer department, he was a member at the volunteer fire department, but his full-time job was DEP, and he actually investigated this fire. He said initially the guy claimed he just parked it. He goes, I don't believe you, because Teslas don't catch fire for no reason. They pulled the black box, which if you don't know, modern vehicles have black boxes in them that keep track of everything you do. And they determined it was involved in an accident. They believed it bottomed out on a curb enough to disrupt the battery pack, causing them to go in thermal runaway. What made the news about this fire is when the fire department did a press release, they said it took 42 minutes and 25,000 gallons of water. But when we watch this quick video next, how much of that 25,000 gallons of water, there's a 20-minute version too, which we're not going to watch. How much of that water do you think got to the individual cells to cool them? So the answer is not a lot. You could see even they had a knock, it looked like it was getting knocked down. As soon as the line deviated to the other side, those horizontal flames started shooting out again. Why it only took 42 minutes though is because the battery pack actually dropped out of the car. Not by design, although that is something that the manufacturers are looking at as a safety feature down the road, putting actual fusible links. So when they do go to thermal runaway, they drop out of the car, you get the car out of the way, now you can put water right on the batteries. This is why it only took 42 minutes. Once the battery pack dropped out, they removed the car and they could put water right on the batteries to cool them. That's just a synopsis of basically what I said. They end up flowing 3 hand lines at 200 GPM each. If you do all the math, it comes out to 25,000 gallons of water. These things are occurring all over the country, many with reignition problems. This one out in Sacramento, they ended up digging a hole, filling it with water. Did it do what they wanted it to do? Yes, it prevented reignition. But here's the problem. What is that water? Hazardous waste. How much does it cost to get rid of it? A lot of money. And you see, that's like a sandy soil. They probably even had to excavate down. If someone tipped off, a Department of Environmental, control, they would probably not be happy about this. And there's going to be a large cleanup bill associated with it. This was the extrication that I actually went to at work. It was a fatal, not because of the accident. The guy had a medical emergency on a pretty narrow one-way street with parking on both sides, and he put his pedal to the floor as he was unconscious in cardiac arrest. They estimate he was doing about 80 to 100 miles an hour. Some noteworthy things. If you look at the intrusion to the passenger compartment, not a lot at all. Yet look at what it did to a parked car. It took that car and it actually threw it about 10 feet in the air, hit a tree, and it bounced back down. And the amount of damage to it, ridiculous amounts. But the Teslas are built very well. As much as everyone jokes, oh, it's a Tesla, they are actually built very, very well. A couple takeaways from the accident. It was obviously not a very big deal extrication. It was a rapid extrication because the guy was in cardiac arrest. Getting the door off provided a couple challenges here and there. The guys tried the regular door handle. It wouldn't release for whatever reason. Spreaders, the body panels are aluminum, so they like to fold over, and then the tool was slipped a few times before they got a solid bite on it, just because of the construction. If we did have to do like a roof removal or a total sidewall removal, it would have put the tools, it would have challenged the tools because of how strong that ultra high strength steel is. There was damage to the high voltage battery pack. We know this because we could see the blue coolant actually dripping out of the battery pack. It did not damage the battery pack to the point where it went into thermal runaway, though. DEP from Connecticut came out. They actually sat on the car for 8 hours while the cops did their whole investigation. And then when the vehicle got transported to the junkyard or to the tow yard, we provided an engine as an escort. That's another big thing with these incidents. Provide an escort for the tow truck in case it does catch on fire. These have known to it's happened multiple times in the past where when they winch the car up onto the flatbed, things jostle, things move, and they re-catch fire. Something as simple as hitting a hard pothole, speed bump, whatever on the way to the junkyard could cause that battery to shift. Send an engine to escort all the way to the junkyard. Here is something we are just seeing the tip of the iceberg with: lithium-ion recycling centers that catch fire. We know that everything is powered by lithium ion, right? Like, it's not just cars, it's power tools, laptops, phones, etc. Where are these batteries supposed to go? To a recycling center. This was an abandoned paper mill that they repurposed. It had close to 200 tons of batteries. They tried putting 1,000 pounds of Purple K and thousands of gallons of water on it. The fire chief was quoted as saying the fire laughed at us. The way they finally got it out, 28 tons of dry Portland cement. This burned for 4 days. We know what's in that smoke. Look at that picture. What do you see all around it? Houses and businesses. They had to evacuate a very, very large area. Now, if you know you have one of these facilities in your jurisdiction, okay, that's a target hazard. We know about it. Let's send a heavy response if, one of these, we get a reported smoke, we get a reported fire in one of these buildings. But what are most people going to do with their lithium ion batteries? They're going to throw them in the trash. So we could have this issue at our regular refuse facilities. I would not be surprised to see this start becoming a regular thing, because these batteries, they only last about 1,000 charges, whether it's EVs, micromobility, your phone, whatever. Everyone notices, after 3 years or so, your phone doesn't hold the charge it usually does. So people toss them out. So the number of these batteries going through these facilities or getting thrown in the trash is just going to skyrocket. I was giving this class down in Jersey. Kid was like, "Oh, I work at an auto body shop." And in the back of the shop, the boss has a stack of bad lithium ion batteries taken out of EVs, and he doesn't know how to get rid of them. So now you go to an auto body shop for reported fire thinking, what? That's a car on fire in the building. Like, we can handle this. This isn't the end of the world. And what are you really finding? A stack of lithium ion batteries burning at 2,800 degrees in the back of the building. This is a situation that we're just seeing the tip of the iceberg with it. Another case study out of Connecticut. All states are pushing a electric bus initiative. One in Hamden, Connecticut caught fire. There's not a lot of information about it because it's all held up in court, but it was in the building getting worked on. They saw it smoking. They pushed it out. It caught fire on and off for about 4 days, and there's not a lot of information released on it. If you do have these buses, because New York is pushing them as well, there are ERGs for them. They're pretty straightforward. It's a 5-step process. The first 3 steps we would do no matter what the bus was: parking brake, open the door, get the people off, shut the master switch off. And then the high voltage shutdown is just 2 little quarter turn switches. This specific bus has 4 high voltage battery packs on the roof and 2 in the rear. The 2 in the rear concern me because they are easily open to getting, I think it's rear-ended by another bus, a triaxle, something significant. We're going to have big time problems with breaching, with thermal runaway, etc. Those are the 2 shutdowns. And here's a view from the rear. You see the 2, battery tubs. They are right there, easily accessible, easily damaged in a rear end collision. Also, they get charged indoors overnight in a warehouse style facility. So everyone remember back to their Fire One days, type 2 construction, non-combustible, parallel cord trusses. Yes, they're sprinklered. Maybe the sprinklers work, maybe they don't, but parallel cord trusses do not do well under heat conditions. All that heat, convected air currents, all the bad stuff's going up, hits those parallel cord trusses that are probably holding up an HVAC system on the roof. Early collapse is definitely a concern for me. I actually went to a hybrid vehicle bus fire riding down in Christiana in Delaware on the University of Delaware campus. That picture is a little deceiving. That is a giant overhead bay door. And as you can see, it is black smoke to the floor. And that's what the entire inside of the building was like. The only way we were able to find the fire was using a thermal imager, stretch a line, move like 10 feet, scan with a thermal imager, 10 more feet, scan with a thermal imager. That's the only way we were able to really find the bus that was on fire. The sprinklers, although they stopped the fire from spreading from bus to bus, the inside of the bus was on fire. You're not getting water on that from a sprinkler system, and it's just making visibility worse and worse, let alone the fact that we were saturated in this smoke that we already talked about what's in it for, a half hour. Not a great deal. New York is pushing for an electric bus initiative. Everyone is. They want all school buses to be electric by 2035. Basically, they want the entire country electric buses by about 2040. It's a huge $1 billion project. It's not going away. So every community is going to be dealing with this sooner or later. If you're not already, there's plenty of electric buses already on the road in various locations. The issues that are going down in New York City, like every single day. 2 of the guys that teach for my company on a regular basis, both work at Squad 61 in the Bronx. They're like, every day this stuff is happening. It's big business down there. People are renting out apartments, and all they're doing is charging batteries in these apartments with like fugazi wiring and plug strips and all kinds of bad stuff. Like dozens, if not hundreds of people have already died from fires that were started by some sort of micromobility or lithium ion device. We had one at work not too long ago, back in May. It came in as an AFA. They arrived on scene to find this hoverboard on fire. What saved this from becoming a big deal was it occurred early in the evening. The batteries were in thermal runaway. They actually found pieces of the lithium-ion batteries lodged in the ceiling as they were popping off. But the occupant was awake and he was able to actually kick the hoverboard down the stairs while it was on fire and then kick it out the front door. If that had been, I think it was around 8 p.m., 9 p.m. If that had been 3-4 hours later, it would have been a complete different story. Just another view of the same thing. And those are the individual battery cells. Armonk, New York. So, local New York department. I gave this class on June 5th. On June 6th, I get a phone call from the from the fire chief saying, hey, guess what? We had a lithium ion incident today. So it was a homemade drone. A teenager built this drone out of stuff he bought on the internet. He was flying the drone. He crashed it, damaged the battery pack, went to charge it. What saved the day for them was his father told him to put it on the granite countertop because it was non-combustible. Don't put it on the carpet. Don't put it on the wood. It started going to thermal runaway. They were home. They were able to get it out of the house. Fire department arrived. Again, it came in as an AFA. They had smoke showing, but again, it was not that big of a deal because they were able to get it out of the house. The one in New Haven, it had caught the floor on fire, but it could have been a whole lot worse. But my question is, what do we do with these batteries, especially if they are still in the building, or even if they're out of the building? What do we do with them? How do we deal with this? Westchester County Hazmat is on the ball with this. They carry what is called cell block. Some of you may have heard of it. It is one of the only things out there right now that we can use for overpacking to contain and smother, for lack of a better term, the battery cells to prevent reignition. So it just gets put in an overpack drum. Cell Block actually sells their own drums that are vented. So if the product continues or the batteries continue to heat up, it has a way to off gas that heat without possibly having a BLEVE occur. I believe they range anywhere from 5-gallon to 55-gallon sizes, and they just encapsulate those battery cells and prevent reignition. But unfortunately, most departments do not have this. I can tell you where I work, we do not have this. So how do we deal with it? And that is, unfortunately, I don't have an answer for you. There really is no easy answer for this, for how we get rid of it. In terms of getting them out of the building, though, that I can give you an answer for. So if we go to a fire and we knock the fire down and we pull ceilings and we think everything's good, if we don't investigate a little bit further into what caused this fire to start, not from like a cause and origin standpoint, but from a suppression standpoint, maybe talk to the owner. Hey, what did you keep in that room? If they say, oh, a scooter or a hoverboard or whatever, we need to do a little bit of digging, because if we don't, we may very well go back to the firehouse and an hour later be back at that address for a fire again. Dig through that sheetrock you pulled down, dig through the debris that's down there. If we find battery cells, they need to get removed from the house. But the question is, how do we safely do that? Let me give you a couple options. What we don't do, the big no-no, is scooping them up with our hands and walking them out. To properly remove them, option number one, you're in full turnout gear on air. I don't care if the room is as clear as the room you're sitting in there or I'm sitting in right here. We're on air. Charged hose line in place and remove everyone out of the room that doesn't need to be there. We are going to take a long-handled shovel, scoop them up, and as quickly as possible, bring them to the exit and get them out of the building. That's one option. Another option, if we're in an apartment building or a large like McMansion, the exit is not immediately close by. Nothing wrong with taking a 5-gallon bucket, filling it up with water, putting the cells in that bucket, and then walking that out. Third option, you're on the 20th floor of a high rise. We're not putting these things in an elevator ever. And I really wouldn't feel comfortable walking them 20 stories down. At the very least, what I can do, fill the bathtub up with water, throw them in the bathtub. Have we solved the problem? Probably not, but we have at least mitigated the issue until someone can come and overpack them or whatever the case is. We don't want to be carrying these things around. So those would be our three options. The other picture there is on the top there is F500. Cell Block is not UL approved to the best of my knowledge, which is why a lot of places don't have it yet. Neither is F500, but F500 is showing a lot of promise. I said water is our weapon of choice in the beginning of the program, and I still stand by that. But F500, it's not foam, but it's almost treated like foam, meaning you're going to use your inline adductor and suck it out at 3% and mix it with your water. It's showing a lot of promise in encapsulating the battery cells and quicker fire knockdown, less chance of reignition, etc. Some places are already carrying it. Not a ton of places are, but I think it's something we can definitely look into in the future. Energy storage systems are typically tied in with solar panels. There's something to be aware of because there is not a lot of rules where they can get installed. You can find them residential, commercial, basements, outdoors, indoors. It's essentially you're putting a bank of lithium ion batteries in someone's unfinished basement, raw wood, wide open. So now you go for that odor of smoke in the middle of the night thinking, it's probably just an oil burner out of adjustment. What you're going to walk into is something significantly different. Lithium ion batteries burning at 2,800 degrees in an unfinished basement when you arrive is going to be not what you initially expected. Cherry City, PA actually had one of these catch fire. I'm not that worried about like the Tesla Powerwall and quality ones catching fire. I'm more worried about people buying stuff on the internet and building their own. These guys went down, knocked it with dry chem. They said every time they hit it with the dry chem, flared right back up. Cherry City is outside Pittsburgh. Pittsburgh Hazmat came with F500. They used it. It actually worked quite well in keeping the fire to the, let's just call it the area of the area of origin. All right, so back to EVs. We're going to wrap this up pretty quick with some tactics stuff. So everything on the left we already talked about, but now it's decision time. What are we going to do? I got a Tesla on fire and I need to make a decision because I'm riding the officer's seat. We can go offensive, we can go defensive, or we can take no action at all. Each have their benefit and drawback, but when possible, one stands out more than the others. That being said, initially, upon arrival, we are always going to start with an offensive attack, meaning we're stepping off fully dressed, SCBA, stretching a line, charging a line. Why? Because we don't know if there's victims. We don't know if there's, maybe there's an exposure I didn't realize, whatever the case may be. I want to be able to put water on this if I have to. Preferably though, even once I get my charge line and I do a further evaluation or size up, what I would like to do is take no action and let this thing burn out. The big benefits of taking no action: it's going to reduce your number of resources you need, the amount of water you are going to need. It's going to reduce your on-scene time. And maybe the biggest one of all is it takes away the reignition hazard because we are letting it consume itself until there is no fuel left. But to make this happen, this is a little checklist of things that we need to take place for this to happen. Number one, the lithium ion batteries themselves are on fire, meaning if the fire is just the guy dropped a cigarette and the passenger compartment is on fire, it would be dumb to let this thing burn. I can stretch a line, put the thing out with 100 gallons of water and be done in 20 minutes and call it a day. But if I can determine, yes, the lithium ion batteries are on fire, I know this because I got horizontal shooting flames from the undercarriage, or I have obvious pushing smoke and fire, from the undercarriage. Yeah, the lithium ion batteries are on fire. So that's one check. Number two, I'm unable to apply water directly on the batteries. That's pretty much a given. With EVs, you're not going to be able to apply water directly on the batteries unless they happen to drop out of the car. Other than that, they are in a location that we can't. If it's a hybrid, yes, I can put water on directly on them, but that's another topic. If there's no life hazard, obviously, yes, if there's someone trapped in the car or in the vicinity of the car, we need to put water on this thing because that, above everything else, we need to make sure that our life hazards are protected. Same thing for exposures. If it's near a house or in a house or building of any sort, we need to take action. Smoke movement can't be a concern. If this thing is maybe not near the building where I'm worried about it exposing the building, but the smoke column is going into an apartment building or a house or an occupied area, that's a problem. What do I have to do? Does that necessarily mean I have to do an offensive attack? Maybe for a minute so we can hook up chain or a winch to it and then move it to a safer location and then go back to no action. There is nothing wrong with shifting tactics throughout. And we'll talk a little bit more about that in a minute. If I can't meet the needed resources, I don't know where all you guys are from. If you're from, very rural areas where you might not be able to get more than one engine on the road at Tuesday at 10 a.m., you might not be able to meet the resources that are needed to make this happen. At that point, we're going to do what we need to do to protect exposures and protect life. But other than that, we may just let this thing burn. If you're in a rural water supply area and you can't get, similar to the not being able to meet needed resources, again, We're going to do with what we can with our tank water and whatever water we have on scene. But if we can't meet the need of the water supply issue, we may have to let it burn after we protect what we have to protect. And then lastly, what a lot of people forget about is the infrastructure damage. If anybody remembers on the news a couple months ago, I-95 in Philly, it collapsed secondary to some vehicle fires. If letting this thing burn is going to cause some sort of catastrophic infrastructure damage, it is certainly not going to be good press for the fire department that we just let this thing burn and now the highway collapsed and it screws up everyone's commute for 6 months. So take a look at where it is, what it's affecting. Again, if it just involves moving the car, we should hopefully be able to do that under the protection of a hand line. If we're under a highway overpass, if all we have to do is pull the thing out and maybe let it rest on the shoulder and let it burn, that's fine. So if we can make all of those check boxes a thing, taking no action would be an appropriate decision. Again, it's going to reduce your time, reduce your water, reduce your resources, and take away that reignition problem. If we have to put water on it, if we have no choice or this is what we choose to do, we're going to do an offensive fire attack, cancel your plans the rest of the day because it is going to be a long duration operation. At minimum, the bare minimum is likely to be about 3 hours. So we're going to stretch a line and we're going to put the fire out as best we can. Once all visible fire is out, we are going to move into what is called the 1545. What that is 15 straight minutes of continuous flowing into the battery pack or onto the battery pack. What I'm looking for is the failure points in the case. If I saw horizontal flames shooting out, there is probably a failure of that case, an opening. I want to direct my stream into that. 15 straight minutes. I like to use nice round numbers. Let's just say we're flowing 200 gallons a minute. That's 3,000 gallons of water I need on scene. If it was shooting horizontal flames out of 2 sides, I would preferably like to put water into both sides for 15 straight minutes. That's doubling our water that we need. Now we need 6,000 gallons of water on scene. Whatever happens, okay, 15 straight minutes. Then we go sit on the bumper for 45 minutes and watch. If anything goes bad, goes towards the negative, you start seeing smoke pushing, you start seeing fire issuing again, start the clock all over again. But if nothing bad happens, we're going to flow for 15 more minutes, just like we did, and repeat the process. Then we sit for 45 minutes. The worst case is at the end of your second 45 minutes, all of a sudden it goes back into thermal runaway. Well, that sucks because now we have to start everything all over again. It is what it is. You see why I'm saying this is probably a minimum 3 hours. It's going to take you probably damn close to an hour to put the thing out to begin with. And then that's 2 hours right there between the 1545. When all said and done, if we've done our due diligence and there's no more smoke coming out of it, there's no more fire and we're happy with it, provide an escort to the tow yard, and that will be that. Just as a side note, real quick, that picture right there at Wakefield, that started as a car accident with no fire, no extrication. It came to rest on a guardrail. When the tow company came to remove the car, it dropped onto the vertical post on the guardrail, which punctured the battery pack. And 5 hours later, they were putting the fire out still. Quickly, we'll go through some of the new equipment that is out there. And I don't know if there's anyone who works for any of these companies, and I apologize if I offend anyone with this, but honestly, a lot of this stuff is very gimmicky. Some of them do have a time and place. Some of them, not so much. One of them is the undercarriage nozzle. So this applies water to the underside because we decided we can't really attack this as a normal car fire. So the thought behind this is it sprays water from the underside. My question for you guys, rhetorical question, is do you think this water that's coming out of this, here it is in use, do you think that amount of water is able to overcome going through a steel case, through the epoxy, and have the cooling effect on the individual cells that are burning at 2,800 degrees? I got my opinion on it. I tend to think probably not. There have been plenty of studies done on it. You can research it yourself. It's not showing a lot of promise, let's say. A device that is out there that I think does have a time and place is the emergency stop device. So what this is you are going to take this device, you turn it on, it goes through its startup procedure. It has 2 sides. One is for Tesla, one is for everybody else. And you plug it into the charge port. And what it does is it tricks the car into thinking it's charging. What that does in turn is makes the vehicle go into park, so it takes away the unexpected movement hazard. If it's in drive, it puts it in park. If it's already in park, it will not allow you to shift it in drive. That's essentially what this does. Again, it has a time and a place. Like if you like this idea better than throwing a 4x4 in the front and back of a tire, cool. Like there's plenty of fire departments that have gone and purchased these. I'm not going to badmouth it. I think it's a decent idea. They do react a little bit differently with each make and model. We actually, a department I trained down in Jersey, they bought one. We used it on my Tesla Model 3 and it worked exactly like it was supposed to. I've seen videos of them trying it on different vehicles. The F-150 Lightning has an actual shifter. It allowed them to put it in drive, but when they tried to accelerate or move, the truck made a very loud, expensive clunking sound. And it kind of lurched, but it wouldn't let them move it. I've also seen lately that there are some aftermarket products that the legality of them, I'm not sure, but you can buy them that will allow you to put your car in drive even when it is charging. Because the whole theory behind this is it tricks the car into thinking it's charging, which won't allow you to move it. These third-party things may be able to override this. I don't know. It's a new thing, so it is a product that's out there. There is a fire blanket that has caught on pretty well, and a lot of people are starting to purchase them. The bottom line with this is it is a containment device. It is not an extinguishing device. We'll watch a little bit of the video. So essentially what you see is they put it over the car, just like these guys are doing. And it knocks the fire down. So it is not an extinguishing agent. Like I already said, these these lithium ion batteries do not require atmospheric oxygen. It will put the car, that blanket will put the car fire out. It will not stop the thermal runaway. It's for exposure protection. I think it's a great idea. Bradley Airport up by me, they have 30 Tesla chargers side by side on the 4th floor of a parking garage. If while the guys are stretching the line, you can get that blanket over the car that's on fire while you move the other cars out of the way, yeah, that's fantastic. But it's not going to extinguish the fire. You got something, Charlie?
Yeah, I don't know if you can see the chat. There was a question about solar farms and lithium batteries. I don't believe they're connected. Solar farms and lithium batteries. If you can see the chat. Is there any lithium batteries, any lithium in big solar farms?
So the solar farms themselves would not, solar panels would not have lithium. What would have lithium is the energy storage systems tied into those, if that makes sense. The solar panels themselves are not lithium, but if that power is going somewhere and being stored, that would be lithium.
Like the battery systems in the homes that you talked about, storage things. And then there's a question here about, sounds like they're talking about the piercing devices, I think, like the Rosenbauer systems.
Oh, we're going to talk about that. Oh, actually, you know what?
that?
I took that video out.
Yeah, I think you probably want to get wrapping up. I think.
Yeah.
I don't know how much more you got.
I'll touch a couple slides. It's we're almost there. I'll
yeah, a lot of good stuff. A lot of good stuff.
Really quick on that piercing device. Rosenbauer sells a piercing device you slide under the car. When it came out, it was $30,000. I believe it's $20,000 now. My advice is save your money. It's a needle in a haystack. All the manufacturers do not want you piercing it's just a bad idea in general. Like, I hate bad mouthing manufacturers and things they make. I can't sugarcoat this one. It's not something you want. Real quick, so these submersion techniques, this is starting to come out for tow companies, where instead of, they don't have 50 feet to isolate, they dump it in this dumpster, fill it up with water. But again, that water now becomes a hazardous waste that needs to be disposed of. You know, that's tough. In terms of charging these things, there's 3 different levels. The bottom line is, if you bring your vehicle consistently to a DC fast charger, if you're doing it every day or every couple of days, you are potentially damaging the battery pack. But level 1 charges at a very slow rate. Like, it does not work for people. Level 2 requires a 220 line. If you live in an apartment building, a condo, a high rise, you're not going to be able to install your own 220 line to charge the car. So you're kind of limited to, you have to bring it to a DC fast charger, which are in high demand. There's not enough of them out there. Coming back, flying into JFK a couple months ago, I had to go to 3 different ones before I could even find one that was open. It's crazy. These DC fast chargers, though, if you do find a vehicle on fire at one of these, one of the first steps we need to take is securing power to it. There are automatic shutdown features, but we can't trust them. So you want to do your best to find the night switch, which should be somewhere in the vicinity. It's usually just a padlock, snip it, shut it down. They're not all that easy. Some of them you have to do a little bit more hunting to where the shutdown is. But we do want to kill power when it is charging, if it's on fire. So basically, to wrap it up, guys, I know we went way over time, which I apologize for, but I think almost everybody hung in there. This is a growing trend that is not going away. Our choices when we arrive on scene is preferably let the thing burn if we can, protect our exposures, and then if we have to fight it offensively because we don't have a choice, prepare for a long duration operation. De-energizing it, that 12-volt battery, that first responder loop, those 2 are going to be our most likely. Find a 12-volt battery, find that first responder loop, take care of both of those, and that will take care of that flow of high voltage. But just remember, we can never take high voltage away from that high voltage battery pack. That's all I got, guys. I will do my best. If anyone is interested in, how can I get my email address up there, Charlie? Is there a way I can type it in?
Do you have a slide? No, you don't have a slide.
I forgot to throw one in there. That was my fault.
Why don't you
Here, what I can do, I'm typing it into the chat right now.
okay.
If anyone has follow-up questions, feel free to email me, and I will be happy to take you guys up on that. If anyone's interested in bringing the full class in, by all means, just shoot me an email. I'll put my cell up there also. And I will do my best also to answer any of the questions in the Q&A.
And you can reach out to FASNY training if you have any feedback, positive or negative on this, suggestions for future training.
Cool.
And if you go into FASNY, you can go into get your certificate, log into FASNY, and you get your certificate. Jason did a great job in condensing a 3-hour class into basically an hour and a half, highlighting all the stuff that we went through. There's a lot of information, and this will probably change in 6 months, right? I mean,
it's changing nonstop.
The technology and all the stuff that comes out, it's really great. Appreciate the stuff that you went through, and there's probably questions coming up here still, but it's in the chat. What else came up?
There's a bunch of questions. I don't know if you want me to keep going, just answer some of these questions live.
Yeah, well, we can stay open.
We gotta go.
Questions.
Yeah, I mean, I'll scroll back to. I'll scroll back to like the early ones here at 7 o'clock. How do we need to account dealing with fires based on differences in EVs when they're sedans versus pickups versus larger trucks to transport goods? So battery location is obviously going to change in all of those. Battery size is going to change in all of those, and voltages are going to change. Like, I had to take the section out about the commercial vehicles and the Tesla Semi. You're talking about 1,000 volts on them. You're talking about very large battery packs. It's just increasing all of our on-scene time and everything associated with that. The only other major change for that is just where we're applying water. If we're not sure where the high voltage battery pack even is, that's why that ERG comes in, great, because it shows us exactly where it is. But other than that, even the commercial vehicles, it is still the same theory. It is still a high voltage battery that is controlled by low voltage electricity. If it's an extrication, an accident, it not on fire, if we can find that low voltage 12 or 24 volt system and shut that down, that will do the same thing for us in terms of shutting down the flow of high voltage. So I hope that answers that one. Teslas are heavy. We had a Tesla spin out and end up 10 feet down in a steep ditch. It broke the winch on 2 roll-back tow trucks. Before we said 1 hour on scene for traffic costs if you need traffic control and you get the appropriate recovery unit. So yes, a Tesla Model 3 is about 4,500 pounds, with the majority of that weight being at the bottom where the battery pack is. I mean, if you're using if it's stuck in, I don't know what the situation was, at this instance, if it was stuck in something. I mean, a 9,000 or 12,000 pound winch, I would hope would have been able to pull that thing out, but obviously it says they broke 2 winches. So I don't know what the individual, the case was but yeah, you're probably going to see tow companies rolling out more of their heavy duty units, more of their rotators to pick these vehicles up versus dragging them. Because one of the other big issues with EVs is you can't drag them. You can't wheel lift tow them. You're technically not even supposed to drag them up on a flatbed unless they're in tow mode or in neutral, both of which you may or may not be able to do depending on the status of the 12-volt system. So they have to dolly them up sometimes, but I think you're going to start seeing tow companies start using a lot of their heavier vehicles, even for passenger size cars, which is going to be interesting because that also increases the bill, which insurance companies are not going to be happy about. And I could start seeing a lot of denied claims. And listen, this is just the beginning of this whole anomaly. It is going to get very interesting out there. We talked about the damaged or broken orange cables. Yes, you're 100% right. We don't touch any of them, no matter what. I've seen a bag deployment from center console and knock. So I actually have that whole. So again, this in the 3-hour program, we talk about exactly that issue with the airbag deploying and hitting a firefighter. That occurred in Dayton, Ohio, in the early to mid 90s. They were doing an extrication. They crushed the brain of the airbag, the control module, and it was a heavy front end damage. The airbag should have deployed, but they didn't for whatever malfunction. When they crushed the box, it deployed the passenger side airbag, hit a firefighter in the face and chest, threw him out of the car. So I actually talk about that exact case in the full program. They're developing Class 8 heavy trucks, tractors, which in time will be in use. Is there any knowledge of these yet? And if so, they'd be handled the same. So Tesla it's called the Tesla Semi. 80,000 pound load, 0 to 60 in I think 20 seconds. They are on the road already. Pepsi bought a bunch of them. They had some issues with them. I know some had to get towed when they broke down. In terms of handling them, yeah, there is an ERG for them, just like everything else. In terms of securing it, it's the funny thing is, even though it's tractor trailer, it is still a little push button at the end of the shift stalk, just like the Tesla Model 3. It has a first responder loop, just like the Tesla cars, and it's still low voltage controlling high voltage. So other than the fact that it's really freaking heavy and the voltages are ridiculously high, like over 1,000 volts, we're still handling it essentially the same. We talked about the solar farm thing. We talked about the piercing nozzle. Please don't buy them. So solar farms will have lithium ion if they have an on-site storage. So yes, that is what we talked about. And actually, if you're looking for something to Google when these go bad, Surprise, Arizona, a few years ago, I forget the date off the top of my head, they had a large storage unit. I believe it was fed by the solar farms.
Yeah, the case study.
What's that?
That was a case study. It was quite a few years ago.
Yeah,
I got thrown back from there.
They sat on it for 3 hours. It stopped smoking. They're like, let's go in and check it out. They didn't see much. There was a deflagration. 4 guys got injured. The captain got thrown 65 feet, never returned to work, career-ending injuries. Okay, I'll list my email there. Some people said they couldn't see the email, so I'll throw it up there. Great point about the dragging. Yes, we don't want to. Yeah, if you do drag these cars, you potentially can cause the motors to overheat and catch fire. So, like tow companies, that's another thing you do want to be pretty upfront with them about. Yeah, do not drag these cars because you can cause them to catch fire. I'll under the last one, the last question there, all the way at the bottom or statement, whatever. I will again. I'll put my email and my phone number.
And they can also Google Northeast Squad, right?
Yes, Northeast Squad Concepts. We are on Facebook and Instagram. We do not have a website currently, but that is going to be changing in the near future. So yeah, I put that answer. If you go to the answered tab under the Q&A, that's where you can also get my my email and contact info. I apologize for not having a slide with my contact info. That was my fault. All right, so I think yeah, that answered all the questions.
Okay, great.
All right, well, thank you, everybody. I really do appreciate you guys. There's still over 100 people in here, so I hope
Yeah,
you guys
that's great.
picked up something. And
I
like
think
I
it
said,
was
more than happy to come give it the full version if anybody's interested.
great. We can expand this topic later on if there's a need.
Cool.
Just let us know.
All right.
Thanks again, Jason.
Thank you,
Great,
Charlie. I very
great,
much appreciate it.
great topic. Great topic.
Awesome.
You can tell by the feedback we got. So
Awesome.
everybody have a great night.
All right. Thank you, Charlie.
Yep, you're welcome. Thank you.
Have a good night.
Yep, you too. Thanks.
Here.